Tuesday evening. All right. Vector value functions continuing. Last time we looked at what they were. Right? Now, because we're math students, calculus on. Starting with the derivative. Who remembers the definition of the derivative?
A set of lines parallel to a given line passing through a given curve.
The limit has 0 of f of x plus h plus over h.
I'm going to modify that just a little bit. Instead of using h, I'm going to use delta x. And h delta x doesn't matter. It just means the incremental change in x. Any guesses on what the derivative of a vector value function is?
The vector's components are the derivatives of.
That's how you evaluate it. That's not the definition. So we'll wait for that. So any idea on what the derivative of r of t would be? The definition.
Is it just that, but f of x is replaced with r of t, and then we do that for each of those?
The exact same thing. Limit as delta t approaches 0, r of delta t plus delta t minus r of t all over delta t, provided the limit exists. Now, think back to Calc 1. Remember having to find derivatives using that definition? Remember how much of a pain in the rear end it was? And now do it 3 times. So we don't want to do that, do we? But wait, how do you find the limit of a vector value function?
Well, you just find the limit for each component, and then you.
Yeah, it's just the limit of each component, right? Which means that limit would go into each component. But that would be the derivative of the component. So the derivative of your vector is the derivative of each component. Oh, but each component, f, g, and h, aren't they just real value functions? Well, can we just tap one? All of your rules still apply. What were the rules? See who remembers all the rules from Calc 1. Ah, good, you said the most important one first, chain rule.
Product rule.
Product rule,
Quotient.
quotient rule,
Not counting all the properties.
what is it? Power rule. Still at least two more. Scalar multiple and the sum difference. Plus all of the rules for the trig functions, the exponential, and the logarithmic. I don't really call them rules, more the actual derivatives. And they should all be on the table of derivatives that's on Canvas. I think the rules are also listed there. So there's scalar multiple, sum difference. Right, so obviously those are the same. We lose quotient rule for vectors because there's no such thing as a quotient of vectors. Product rule. How many products do we actually have for vectors? I know which two you're thinking about. Dot and cross. There's one more.
Scalar.
Scalar. Instead of multiplying by a number, can't you just multiply it by a scalar function? That's your scalar product rule, which is exactly as you would think it would be. Then you have your dot product rule, which is exactly as you would think it would be. Then you have your cross product rule, which is exactly what you think it would be.
On the last slide for the scalar product rule, it listed on the left side F and R, but then on the right side F and U. Is that important?
I just used the wrong function.
Oh, okay.
I don't remember if it was supposed to be U or R that I used, but either change one U or one R or two U's, and it's easy to change the R. do you think? Can we have a chain rule for vector functions? So what was the chain rule used for? What type of function?
Nested functions?
What is the mathematical term? Well, technically nested is, but that's more for coding. What was the mathematical operator? Yeah, what is that called? Composition. Chain rules used for composite functions, like nested. Same thing, we just use nested for coding, generally speaking. Or something like if you have a nested square root, right? Square root within a square root, that's what we say before. So can you have a composition with, can you have a composition involving vector value functions?
Yes.
There's a caveat. Can you take a vector valued function and compose it with a vector valued function? That you can't do. So when you do composition, it can only be a vector with a scalar. You can't do a scalar with a vector either.
Scalar inside of a vector?
Yeah, so
Oh,
it's
sorry.
it's a vector composed with a scalar.
I see, thank you.
And again, the chain rule is just what you think it would be. Now, in actual practice, we don't use that. Because why not just evaluate R of F first and then take the derivative? Right, because R of F is going to give you 3 new component functions. So why not just do that? Same thing with in practice. I'm not going to be using the dot product and cross product rules. Because it's generally easier just to take the dot product or the cross product first and then find the derivative. Those 3 are public use. But again, you really don't have to, because you could just find the resultant vector in each case first, then take the derivative using Calc 1. Also, if R dot R is C, then R dot R prime is 0. Which means if the magnitude of R is constant, then it is perpendicular to its derivative. Because remember, U dot U is the magnitude of U squared, right? So if R dot R is C, then the magnitude of R is the square root of C, which is a constant. Well, now we can find tangent lines in 3 dimensions. And so we can now find tangent lines with space curves. If C is a curve defined by the vector function r, and r prime exists at t naught, a tangent vector at t naught is any vector such that when the tail of the vector is placed at r of t naught, v is tangent to c. One such example of a tangent vector is r prime. So if you have a curve C, defined by r, then r prime is tangent. Right, r prime of t naught would be tangent at t naught. Which means that would serve as a direction vector for your tangent line at the point. However, generally speaking, when we think about direction vectors, we want it to be unit. Right? We want the vector to just give us a direction and not do anything with magnitudes. So a length of 1 serves that purpose. That's where the unit tangent vector comes in, the principal unit tangent vector. And how do you think we find it?
I'm guessing the same way we always find the unit vector, which is to divide, in this case, the derivative by the magnitude.
Okay, so be careful. I know what you're saying.
Yeah.
It's not divide.
Multiply it by the reciprocal of the magnitude.
Yeah, we write it r prime over magnitude of r prime, but that is technically scalar multiplication. Right, so 1 over the magnitude of r prime times r prime. That is what we call the principal unit tangent vector. And we represent it with a capital T. Oh boy. We are not going to like that vector for very long. What is an integral?
I want to say the area under a curve, but I have a feeling it's not quite what we're looking for.
You're not 100% correct. It's a signed area between the curve and the x-axis.
Mm-hmm.
But that's the geometric. That's not what I want. I want the arbitrary. And I honestly wouldn't be surprised if you don't know this, because I'm probably the only who still teach the definition in Calc 1. does Riemann sum sound familiar? Integral is limit of the Riemann sum. Generally written this way. Where C is the set of sample points and P is a partition. Any partition and then that symbol, norm of delta approaching 0, just represents the norm of delta represents the length of the largest subinterval. You may have seen it like this. Limit of n goes to infinity of r sub n. Or L sub n or M sub n. Those are the three Riemann sums that are usually studied in Calc 1. Right endpoint, left endpoint, and midpoint. Those are not the only Riemann sums. The right endpoint, left endpoint, midpoint are useful in the sense that they give us a way to pick our sample points and a way to pick our partition. Right, first off, for all three of them, the partition is the same. It's called regular, which means every subinterval is equal length. So n would just be b minus a over n. I'm sorry, delta x, your length would be b minus a over n. Where n is your number of subintervals. For the right endpoint, you choose the right endpoint of each subinterval. Left endpoint, you choose the left endpoint of each subinterval. And midpoint, you choose the midpoint. However, those choices are only good on a very limited number of functions. So nowhere does it say a partition has to be regular. You can have a partition where all of your different lengths. And you don't have to choose the sample point the same way from each subinterval. I could choose the right endpoint for one of them, the left endpoint for the second, the midpoint for the third. I could find a quarter point for the fourth, 3/4 point for the fifth. I could choose the right endpoint plus 10 to the minus 6 for one. Which really makes working with Riemann integrals a pain in the ass. Here's some trivia. Is the Riemann integral the only integral? Nope. Do you know another one? Another commonly used one is called the Lebesgue integral. Which is way more useful than the Riemann integral. It is unfortunately also more of a nightmare. It involves what's known as measure theory. Which is the grad topic. studied it in grad wheel too.
Real analysis.
Real analysis too. Grad level. So, what do we think the definition of an integral of the vector value function is?
It's the same thing.
Sadly, no. Does not work as nicely. So we don't define it. I will not give the formal definition because it's well beyond the scope of a sophomore level Calc 3. It does involve form of a Riemann sum, but how you find that Riemann sum is now a lot worse because we're dealing with vectors. So instead, I define it in terms of the fundamental theorem of calculus, which is how you evaluate it. Now, you're familiar with the terminology of indefinite integral and definite integral? Yeah, the terminology is bunk. It's bogus. There's only an integral, which is what is referred to as a definite integral. The other one is known as an antiderivative. So I define both of them here. To evaluate the antiderivative of a vector, you just find the antiderivative of each component, which again makes sense because antiderivative is the inverse operation of a derivative. And since the integral is just a limit, and we know that we can pull the limit inside of the vector, finding an integral is just integrating each component. Again, for the sake of space, I think I will split this into two different slides. Nuisance about this. Play that game. So first we'll find dRd2. See who's really paying attention. What's that notation called?
What?
Is that how it's pronounced? I never saw it as Eaton's.
I've never heard of that.
Who invented calculus?
Newton or Leibniz?
One of them invented it.
Was it like both independently, or did Leibniz only?
Well, independently, yes, but someone was actually first.
Isn't it?
Nope.
Leibniz?
Yep.
No.
So why does Newton get credit?
Is it more popular?
Didn't he like burn a lot of the records of Leibniz's estate after he died or something? Was that somebody else?
It wouldn't surprise me if Newton did it. Newton was actually an asshole. So the society that published the papers, who was the president? Newton. So he didn't publish Leibniz's, even though he submitted it first and published his own. That's why he gets credit. So I repeat, Newton's an asshole. This little fun trivia. A lot of the people who are credited are not actually the ones who discovered it first. They were just the more popular ones. Like Maxwell, for instance. Maxwell's equations. Yeah, he actually only did one. The other three were other people. And I know I'm not going to write that out every single time. But this is what we're doing. Derivative of 3 cosine.
Minus 370.
Derivative of 3 sine. Derivative of 4t. There's the RBT. Oh, that was easy. It's Calc 1 all over again. Oh, how we missed Calc 1. Even though when you took Calc 1, you're like, why do I have to take this? This is stupid. Now you're Calc 3. I don't want to do that. Just wait, it gets worse. So what does that mean? And how do you find the second derivative? Derivative of the derivative. What is that derivative?
Negative 3 cosine t, negative 3 sine t, 0.
It's your second derivative. Let's say R represents position. What's that? What's that?
Oh dear.
That means we have a physics day coming up. Where we examine motion in space. What's the derivative of acceleration?
Sure.
What's the derivative of jerk? Snap. It's the change in snap. Crackle. It's the change in crackle. Yep. Wow. That is not a joke.
They just sound like even successively more sudden bursts of motion.
That is quite literally useless knowledge. Because you never go beyond acceleration in physics. They also have names for the fourth position. So position's a rate of change. What's the rate of change of? They have a name for that. I don't know what it is because again, it's absolutely useless information. And it's not as cool as snap, crackle, and pop. But I think they go up to the second antiderivative position in terms of naming. Such cool information, but completely useless. It's definitely a Jeopardy question. And definitely something I could see myself asking on an exam to see who's paying attention. Are they the same? Which means if we use this notation, we cannot write that way. They are two different things. One on the left says find the derivative first and then find its magnitude. One on the right is the derivative of the magnitude. So be careful with your notation. What was the RDT?
-3 sine t. We could have sine t.
So what would its magnitude be?
9 sine squared t plus 9 cosine squared t plus 16.
Which is what?
5.
Triggers. yeah, I'm missing one earlier. I skipped one somehow. Oh, I skipped one. Move you down here then. Right, so again, not to be confused with what was the second derivative of R?
-3 cosine t, -3 sine t, and 0.
So what's its magnitude? Quite clearly, right? This one I think I will also split. Into two. So now the question is, yes.
Would it, would it be the derivative of u cross v plus the derivative of v cross u? Or, or would it be u cross the derivative of v? Make a note of that.
So I want to do two cross products or just one? On the right side, if I do, oh no, I won't get a 0. I'll get a 1 at least. Makes things a little easier. To that. Cross V first. I think that's easier. So rewrite V. and then take the cross product. Tell me what you got.
I got negative t cubed cosine t, negative t cubed sine t, and negative 5t squared cosine t minus t sine t.
That?
That's what I got.
Sure.
I'm gonna say yes.
Sure.
Out of 10, we'll go with 7.
So if you're wrong, you have to cut off 7 fingers.
7. Oh, well, let's see, if you start with my left hand. Yeah, I'm sure.
With 7 fingers.
No, all right.
It's not very short. That's the right cross product. So that's what we're differentiating. They require a bunch of product rules. So this would be a good test. What's that? The derivative.
I got negative 3t squared cosine t plus t cubed sine t. Right.
What about the second one?
Negative 3t squared sine t minus t cubed cosine of t.
You said that?
Yes. Yeah, that's, I just said it in the opposite order, yeah.
What about the third component?
I got negative 10t cosine t plus 5t squared sine t minus sine t minus t cosine of t.
So this,
Sine t minus sine t. Yes.
Should we just move the 5t squared sine t to the front?
oh, that doesn't matter. I might actually rewrite it and do that. This one's upsetting. Teardrops coming down too. This is just very upsetting.
I see. I see.
Very, very upsetting.
We could combine my terms for the z coordinate.
So I'm going to write that 5t squared first. Write minus sine t. And what should it be?
Minus 11t cosine.
Very sad that you didn't combine like terms.
Sorry.
200 points off your exam.
Okay.
It's only out of 100.
Well, that's going to be a problem for me.
So the best you can hope for is a minus 100.
I'll have to just try my best.
Yeah, there's your derivative of the cross product. So again, pick your poison. Do you want to do two cross products, then add them together, or do the cross product first and then take the derivative? In this case, it might actually be easier just to do u prime and v prime separately and then take the cross product before the product rule. So derivative of u dot u. How do you want to do it? Which gives you what?
U squared.
Now from here, what do you want to do?
U. You can't like just differentiate that as 2U and then just say, so you can.
Well, I mean, you can, but then Tom Lee can't define U and D and T and all stuff together. Which is not the worst thing in the world. But it might be better just to find U squared first. Because it's easy.
I'm confused about U dot U making U squared. What?
It's a property of dot product.
Okay.
Take any vector dot of itself, you get the magnitude squared.
Okay.
What's that derivative?
T cubed plus 2T plus 6T plus. They said that.
Easy. Show that U dot du dt is, vector U dotted with D vector U dt is the same as U times du dt. Let's trigger some trauma. Proof! Find U to be U1, U2, U3, where each component is a differentiable function of T. Then, what does U equal?
Square root of U1 squared plus U2 squared plus U3 squared.
What is du dt?
U1 prime, comma U2 prime, comma U3 prime.
And I'm doing the derivative of the vector U.
U1 in the numerator, U1 plus U2 plus U3, and in the denominator, square root of U1 squared plus U2 squared plus U3 squared.
You're so close. How'd you get it?
I used the chain rule.
You didn't use it properly.
I didn't use it properly.
I think you got the square root of the denominator, right?
No, he has that. That's not what it is.
Oh. It's in the denominator is 2.
So for the sake of space, I'm going to write it with a negative exponent.
That's what I got wrong, right? And the denominator is supposed to be 2.
I agree with that. But you did not use chain rule properly. What is the derivative of U1 squared plus U2 squared plus U3 squared?
2U1 plus 2U2 plus 2U3.
You forgot chain rule. Isn't U1 a differentiable function of T?
Yes, I'm thinking of it like a variable.
So general power rule says it's 2U1 times the derivative of U1.
Okay, right.
And now we simplify that. That denominator, isn't that just U?
No.
Stop.
If U1, U2, and U3 are
It's not.
if U1, U2, and U3 are different,
Look at what we define U to be.
oh, then yes.
It's just the magnitude of U in the denominator.
Right.
That's nice. What about the numerator?
Is that the derivative of U?
You, oh, never mind.
Undo a dot product. Not just U1, U2, U3 dotted with U1 prime, U2 prime, U3 prime. But isn't that first vector just the vector u? What's that second vector? So what do we say? Du dt is equal to that. I could draw a straight arrow, that'd be nice. There we go. So multiply both sides of the equation by u and you get your result. So the proof is complete. You can do that on your own, right? Maybe it's an exam question. Maybe something with cross product stuff. Ask you to draw something about u cross u prime. I'm starting to see some worried faces now. Excellent, good. Good job. Now, here's where it gets fun. Integrals. What were the rules for integrals?
There was a definition.
Well, we had a definition, but I'm talking about when we studied integrals. What were the rules?
Is integration by parts one? Or is that just
Yeah, by parts.
trig substitution?
You have trig sub. You have u sub. What else did you have?
With power rule,
Power rule for integration. What else did we have? Partial fractions. What else did we have? What if the function has no antiderivative?
Is that what we got?
That's for limits.
Taylor series or
Taylor series. Let's see if these ring a bell. I'm probably gonna have one person cringe because they're gonna remember this from the spring. Trapezoidal rule, Simpson's rule, which are numerical techniques which involve coding. We also have improper integrals, don't we? Oh. They all still apply. Except it's now worse. Because one component could require trig sub and partial fractions. The next component then could just not be defined, so you have to use a numerical technique, which means you have to use a numerical technique in the whole bloody thing. Then it could be, oh, well, look, this one is discontinuous. Now it's an improper integral. Now you set up the improper integral, and that requires integration by parts. And they said Calc 3 was easier. So unfortunately, if one of your components does not have an antiderivative, you have to use a numerical technique on the whole thing. And the technique used is Simpson's by default. To do it. We'll see if we encounter any problems like that. Three. Oh, that's easy. It's just 30. T cubed plus 14 to the 7th doesn't have an antiderivative. Yes, it does. Is the integrand discontinuous anywhere over the interval? So this is real simple. What is the antiderivative of t cubed plus 14 to the 7th?
1 4 2 4 plus 4 sevenths or 4 eighths to the 1/2 to the 8.
And then we use fundamental theorem of calculus. What about t? Does t have an antiderivative? Is there a discontinuity? No. What's the antiderivative?
T squared over 2.
What is 2 to the 4th? Minus 1. So we have 15 quarters. What is 2 to the 8th?
2 to the 6.
Minus 1. What is 15 quarters plus 255 over 2? What's 2 squared? Over 2. Minus 1 squared over 2. So actually, could have just gone with 2 squared minus 1 squared all over 2. There's your integral. Evaluate this antiderivative. I'm not going to use the prime notation here. Physics person, you recognize that notation?
Vector notation? Oh, no, never seen that.
What are they teaching you over there?
I don't even know this.
It's called dot notation.
Maybe they recognize the cross products right there, but.
That dot represents ddt. Yeah. We physicists don't use prime, so we use dot.
That's stupid.
Isn't the DBT like that one
Sorry.
pesticide?
We already have, why pick something that ain't broke?
Minus 800 points from your exam score. What were you saying? Sorry, this is all.
You said DBT, isn't that like that one pesticide?
You mean the one that's now outlawed?
Yeah.
Yeah. Because it actually works, so that's outlawed.
Works too well.
Freaking steelers.
Works on humans too.
What is this derivative? You got it, right? How's that simplify? I should make those look like these. Specifically, look at that first term.
That's it.
Is it?
Something for us itself is zero.
So why are you asking me if it's zero? You should be telling me it's zero.
It's zero.
That first term is just zero. Well, technically it's zero factor, but it's not. What happens if you add the zero vector to a vector? Stays the same. This is what I would take the big box. What's that antiderivative? Hmm?
So,
What do you mean by itself?
the v vector times the derivative of the v vector.
When you say times,
On a cross section.
that,
No, wait, the second derivative of that. No, but
almost. You're missing something.
C.
Not just C now. No, C vector. Questions on the calculus of vectors?
I have a question. When we think of, not that it really has come up or anything like it yet, but like when we're taking the integral of something in 2D, we can picture it as that area between the curve and the x-axis. Is there some similar correspondence with vectors and its coordinates and its, I guess, space? Maybe not. Maybe not practically.
Yes.
Okay.
Let me get back to you.
Okay.
I think there it is.
Like I'm picturing like a shape coming down from.
I think there it is.
Okay.
That would be surface F parameterized.
Yes. Okay.
So you have the project due on Thursday. We also have an exam coming up. This is week 4, which means Thursday, a quiz goes up. And next Thursday is your first exam. Coming up already.
Question about the project. I know you only want each group to submit. I know you want each group to submit one completed project. Do you want one group member to submit the completed project, or do you want each member to submit the same?
No, only one person has to upload it.
One person upload the one paper.
It grades by group, so
Oh, okay.
if every group member's upload something, I'll see every single file.
Right. And you don't want that.
So just one member has to upload it.
Okay. And everybody else.
And when I grade it, again, it's graded by group. So I enter a group
Okay.
grade and it assigns that grade to everyone.
Okay, so we won't have to worry about the Canvas entry if we did. Okay.
Because essentially every group member shares an entry.
Right. Got it.
So even if you comment, every group member's going to see that comment on the assignment comments.
Oh, I see.
And if I comment, then every group member will see that comment.
Oh, okay, so if one group member submits in their Canvas, the other group members will
Will see
see.
it, yep.
Oh, okay, cool. Huh.
I didn't know if you used to do that.
I think Blackboard Ultra can do that now too.
What?
It's the newest Blackboard. They're trying to mimic Canvas. I'm not going to lie, the original Blackboard layout was way better. It's far superior to Canvas, but
Is Blackboard a thing like people actually use?
no, other two schools use Blackboard. We used to use Blackboard and then we had to switch to Canvas for some dumb reason. Canvas is awful.
Canvas is something.
I'm liking it more and using it, but it's still not as good as Blackboard.
Now that you're used to it,
It is better than Teams though.
well,
So, there's still like 13 minutes left. I would recommend that you discuss your project during that
That's